Hey there my students, I see you've come here to learn some more. Well, I have the exact topic in mind for us to learn about, and we are going to have a blast. So today, we are going to talk about these super dense objects which actually not many people know about. Pulsars. Let's start with a little bit of history, shall we? So long ago, I'm at least long enough that my hair still used to be black. There was this absolutely stellar researcher named Jocelyn Bell, who, like all of us here, was looking into the mysteries of the universe. In 1967, she stumbled upon this unusual marking in her observation papers. Now, the source of this object was too fast and too regular to be a quasar. I mean, it took only about 2.5 centimeters of the whole chart paper. But Jocelyn recognized its importance, and that, my friends, was the first evidence that the humankind had of the existence of pulsars. Let's go dig a little deeper now. So pulsars are these spherical compact objects found in the outer space. And I don't know if you would believe me or not, but they can be as large as small cities and have a mass greater than our sun. I mean, that's almost as much mass as my body has. In addition to this, here's another thrilling fact about pulsars. They're actually the leftover remains of exploded stars. And if you try to see it from the earth, which in fact I'd recommend you guys doing, you would see this rhythmic flickering of light, or something like a flickering star if you must. But here's the catch. Neither is the light flickering nor are pulsars anywhere close to being actual stars. The thing is, pulsars do seem to flicker when observed, but that's only because they spin at this huge speed. In fact, they really just emit these two narrow, but steady, mind you, beams of light in the opposite direction, which makes them a sight to behold. These pulsars are made out of what we call a supernova. Let me break it down for you. When stars with mass anywhere between 1.5 to 3 times the mass of our sun run out of their hydrogen fuel and collapse on itself due to its weights, a massive, breathtaking explosion occurs, which, as aforementioned, is called a supernova. After this wondrous phenomenon of stellar death, what's left is a ball of neutrons, which yet again surrounded by numerous layers of neutrons and protons. So that's why pulsars aren't your typical living stars, but do belong to a family of neutron stars. Phew, that's a lot of information, isn't it? Well, here's a rather amusing fact about pulsars that I read somewhere. Okay, so picture an average sized sugar cube in your mind. Done? Now, if we were to take a sugar cube sized particle of a pulsar, it will weigh at about 1 billion tons. Do you know how much the Mount Everest weighs? 1 billion tons. This means a sugar cube made out of a pulsar weighs as much as the Mount Everest. Mind-boggling, isn't it? Now, they weigh so much because of their super dense mass, which actually means that their gravitational pull is downright enormous. I mean, the last I heard, those scientist guys were saying that the gravitational pull of a neutron star is about 1 billion times more than the Earth's. And with the gravitational pull as large as that, they ought to be crazy magnetic, right? Well, here's the deal. The magnetic field of a pulsar is anywhere between 100 million to 1 quadrillion. Right, 1 quadrillion times stronger than that of a planet Earth. I wish I was as magnetic as a pulsar. I mean, it seems that all I can do is to repel people away. Before we call it a day, there is another extremely captivating aspect of pulsars I wanted to tell you about. It's the way a pulsar spins. To illustrate how extreme it actually is, did you know that a pulsar can spin completely once in 1 second? Keep the fact in mind that a pulsar is usually bigger than both you and me, as well as everyone else who lives in a 40 kilometer radius of you combined. So once completed in a second sounds pretty amazing, right? But that was the speed of the slowest pulsar that has been observed by the scientists until now. The fastest, by the way, is about 700 times in a second, and that's no small feat. Now you see, to spin that fast, sometimes these pulsars need an additional source of energy. So what these bad boys do is steal. I know that's pretty juvenile, but let me elaborate. So what happens is these pulsars, which are labeled as millisecond pulsars, siphon off the momentum and matter from their companions to propel their motion. And in fact, whenever a scientist observes a pulsar sucking the life from a star, it's very ironically called a black widow or a redback star at Earth. I sure did have a good laugh when I heard about it. That's a wrap on the elementary knowledge you need to have about one of the most extreme yet enigmatic objects of our outer space. To be honest, my brain is more saturated with knowledge than the air ever gets on a rainy day. So I'm going to sign off. But if you have any doubts, feel free to revisit my video. I'll always be glad to help out my students. So students, rock the world.